Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Up to last session, we have seen some of the basic concepts of matrices and we have solved the system of homogeneous equation and system of non-homogeneous linear equation by matrices using Gauss elimination and Gauss-Jordan elimination method. Now, in today's session, we are going to start with the topic eigenvalues and eigenvectors. Now, first of all, what is eigenvalue and eigenvector? Let A be any square matrix of order n, and if there exists a non-zero column matrix X and a scalar lambda such that Ax is equal to lambda x, then lambda is called the eigenvalue and a capital X is called the corresponding eigenvector. That means if you have A into X is equal to lambda into X, where X is any column matrix of n cross 1, then if both values are same, that means Ax is a scalar multiple of vector X, then we are going to say that lambda is a eigenvalue. And whatever the vector X we have, it is called the eigenvector corresponding to lambda. Now, the eigenvalues are also known as characteristic roots or latent root or spectral values or the proper roots. Okay. Since we are starting with a definition, Ax is equal to lambda x. So we can write it in the form of Ax is equal to lambda into Ix, where capital I is nothing but it is a unit matrix. So if we are going to write down in the form of Ax minus lambda Ix is equal to 0, then x will be common out and you will have A minus lambda I into x is equal to 0. Now using this, the matrix, whatever the A minus lambda I matrix we have, that matrix is called the eigenmatrix or a characteristic matrix. And determinant of A minus lambda I, it is called the polynomial, eigenpolynomial or the characteristic polynomial. The polynomial of lambda have a order n. That means this is the polynomial of order n. Now, if you are going to put the determinant of A minus lambda is equal to 0, that means you are going to equate the determinant with 0, then that is called the eigen equation or the characteristic equation. And whatever the roots of this equation we have, that are called the eigenvalues or the characteristic values. That means by factorizing and solving this equation, we have to find the values of lambda. Whatever the values of lambda we have, that is called the eigenvalue of a matrix. Okay. Now, properties of eigenvalue. The first property, the sum of the eigenvalues of a matrix is the sum of the principal diagonal elements. That means if you are going to add the eigenvalues, whatever the eigenvalues you have, it is the sum of them is same as the sum of the principal diagonal of the given matrix capital A. That means it is trace of A. Second property, the product of eigenvalue of the matrix is nothing but it is the determinant of a matrix. And the eigenvalues of the triangular matrix are nothing but they are the diagonal element of the matrix. That means if you are given any upper triangular or lower triangular matrix and you have to find the eigenvalues, then they are directly the diagonal, principal diagonal elements are going to be eigenvalues of that matrix. The eigenvalues of two matrices A and A transpose are going to be same. That means the eigenvalue of A and A transpose are always going to be same. Now the eigenvalues of A inverse and that is reciprocal of the eigenvalue of original matrix A, they are going to be inverse of original matrix A. That means if lambda is the eigenvalue of matrix A, then 1 upon lambda is eigenvalue of A inverse. Okay. If lambda is eigenvalue of matrix capital A, then lambda raised to k is eigenvalue of A raised to k. So, if you are aware of the eigenvalue of original matrix, then you will have the eigenvalue of A raised to any power, where power may be positive or may be negative. In the case of A raised to negative power, determinant must not be equal to 0. That means lambda is not equal to 0. Now, if the lambda is eigenvalue of matrix A, then lambda plus or minus k is an eigenvalue of A plus or minus ki. That means if you are finding the eigenvalue of A plus ki, then it will be a lambda plus k. And eigenvalue of A minus ki, that will be a lambda minus k. If lambda is the eigenvalue of matrix A, then k into lambda is an eigenvalue of k into A, where k is any integer. Okay, and note that a matrix A into A transpose have a same eigenvalues, but eigenvectors are going to be different. And in above all cases, such as inverse, A raised to k, A plus or minus ki, in that case your eigenvectors also remains same. Okay. Now we are going with a characteristic equation of a matrix. First we are going to define the characteristic equation of 2 cross 2 matrix. See, you can use the simple determinant method because we have written the determinant of A minus lambda A is equal to 0. But here we have written it in a direct form. If you have 2 cross 2 matrix, then the characteristic equation is given by lambda square minus S1 lambda plus S2 is equal to 0. And same manner, where S1 is nothing but it is sum of principal diagonal, that means it is trace of a given matrix, and S2 is nothing but it is a determinant of a given matrix capital A. Okay, and put this both values in equation, that will give you the characteristic equation. Now, for 3 cross 3 matrix, you have lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Then S1 is again the sum of principal diagonal. That means it is trace of it. S2 is nothing but it is sum of minors of principal of diagonal elements. Okay, that means you have to find out the minor of each diagonal element and you have to add them all. And S3 is nothing but it is the determinant of it. Now we are going on to the example. If A is equal to 3 minus 1 1, minus 1 5 minus 1 and 1 minus 1 3, then find the eigenvalues for the following matrices. First one is A, second one is A transpose, third one is A inverse, fourth one is A square, fifth one is 5 into A, and sixth one is A plus 2i. So first we have to find the eigenvalues of matrix A. Then we are going to use the property, okay, that we have written earlier. So we are starting with the solution. A is equal to given matrix 3 minus 1 1 minus 1 5 minus 1 and 1 minus 1 3. So the characteristic equation is going to be a determinant of A minus lambda is equal to 0. That is 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 and 1 minus 1 3 minus lambda is equal to 0. Now see, if you can solve this determinant by simple determinant method and you can find out the characteristic polynomial or characteristic equation. Otherwise, we are going to use our method of S1, S2 and S3. So we are starting with lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So S1 is nothing but it is sum of principal diagonal, that means trace of it. So if you are going to put the values, then it is 3 plus 5 plus 3 and that will be a 11. Same manner S2 is nothing but sum of minors of principal diagonal, That means if you are starting with a minor, then first minor of 3, that will be a 5 minus 1 minus 1 3. Then minor of 5, that will be a 3 1 1 3. And minor of again 3, that will be 3 minus 1 minus 1 5. And if you are going to simplify this, then you will have 15 minus 1 plus 9 minus 1 plus 15 minus 1. And the final answer you get is 36. Same manner, S3 is nothing but determinant of original matrix A. So if you are going to find the determinant, then you will have 3 into 5 is a 15 minus 1. Minus minus plus 1 into minus 3 into plus 1. Plus 1 into minus minus plus 1 minus 5. And that will give the answer 36. So S3 has a value 36. Now put these values S1, S2 and S3 in characteristic equation. That will give lambda cube minus 11 lambda square plus 36 lambda minus 36 is equal to 0. And if you are going to factorize this, then you will have the factors lambda minus 2, lambda minus 3 and lambda minus 6. So that will give the eigenvalues lambda is equal to 2, 3 and 6. Now, these are the eigenvalues of A. So if A has the eigenvalues 2, 3 and 6. And if you are going to find the eigenvalue of A transpose, then it will be going to be same as A. That means it is also 2, 3 and 6. Now, if you are going to find the eigenvalues of A inverse, that means they are nothing but they are lambda inverse. That means 1 upon lambda. So that will give you the eigenvalues 1 upon 2, 1 upon 3 and 1 upon 6. That means A inverse has the eigenvalues 1 by 2, 1 by 3 and 1 by 6. Same manner, A square has the eigenvalue lambda square. That means you have the values 4, 9 and 36 for A square. Same manner, 5 into A has the eigenvalue 5 lambda. That means we are going to multiply lambda by 5. So that will give you the eigenvalues 10, 15 and 13 for 5 into A matrix. And same manner, the eigenvalues of A plus 2i matrix is nothing but it is a lambda plus 2. So that will give the answer 4, 5 and 8 for the matrix A plus 2i. These are the eigenvalues of given matrices. If you are going with eigenvectors, then other than A transpose, all the matrices have a same eigenvector as the eigenvector A matrix have. Okay. Now we are going with one another example. If A is equal to minus 1, 1, 1, 0, 2, minus 1, 0, 0, 3. Then find the eigenvalues for the following matrices. First one is A, second one is A transpose, third one is A inverse, fourth one is A square, fifth one is 5 into A and sixth one is 6 plus A plus 2i. See here, the given matrix is in a diagonal form. Correct? It is the upper triangular matrix. So all the entries below the diagonal are 0. That means it is the upper triangular matrix. So the diagonal entries are going to be eigenvalues. And therefore your eigenvalues are 1, 2 and 3. Now once you have the eigenvalues, then as in above example we have seen A has eigenvalue lambda, that means it is 1, 2, 3. Then A transpose also has eigenvalue lambda, that means it is 1, 2, 3. Same manner A inverse has eigenvalue lambda inverse, that means 1, 1 by 2, 1 by 3. Same manner A square has eigenvalue lambda square, that means it is 1, 4 and 9. Same manner 5 into A has an eigenvalue 5 lambda, that means it is 5, 10 and 15. And the eigenvalues of A plus 2i are going to be a lambda plus 2, that means it is 3, 4 and 5. So these are the topics which we have covered in today's lecture. If you have any doubt or any query regarding this, then please feel free to contact me. Thank you.